Hello students, now we're going to start third class on thermodynamics. In the previous class we finished at work, and what we learned about work? P delta V. What is work? P delta V, right? Work is, we said it's P delta V. So whenever volume is increasing, we say that work done is positive, and whenever volume is decreasing, we said work is negative. That means if gas expands, that is final volume is greater than initial volume, work is positive, right? And if gas is compressed, then what will happen? V final will be less than V initial and work done is negative, right? So P delta V, we said that this is work done when pressure is constant. And if pressure is changing, then we said integration P dV. Okay, P is variable. And if it is given in the form of graph, then its meaning is area under. This is area under PV graph. This is area under PV graph. And maximum questions in this one will be asked on area only. Right? So let's see. Okay, this all we have done in the previous class. I've just written it. Okay. So let's see. Let's make one graph. Okay, this is pressure and this is volume. Okay, and suppose the graph is given like this. Okay, here pressure you can say is P1, here pressure you can say is P2, this is V1 and here is V2. Okay, and we have to find work done in process AB. Let's say this is A and this is B. Okay, so work done in process A. Now what that is? Area under the graph. What is area under the graph? Area under the graph means this entire thing is area under the graph. Correct? So if I can make two graphs out of that, not two graphs, I am splitting this. What split? I am splitting this into two parts. One is this triangle and one is this rectangle. I can do that. Right? So rectangle's area if you see. Okay, rectangle means is what? Length into breadth or height into this width. Okay, height is what? P1, because this is the origin for you. Okay, so this is P1 and this is V2 minus P1. So its area I can say is P1 into V2 minus V1. Rectangle. Now triangle. Triangle is what? Half base into height. So base is V2 minus P1 and height is P2 minus P1. So its area is half P2 minus P1 into V2 minus P1. Correct? Then we have found areas of both. Now add it here. So we'll say half P2 minus P1 into V2 minus P1 plus P1 into V2 minus V1. Okay, take V2 minus V1 common. What you have? P2 by 2 minus P1 by 2 plus P1. Okay, so P1 minus P1 by 2, that is P1 by 2. So what we are getting? It says P2 minus P1 into P2 plus P1 by 2. P2 plus P1 by 2. That means, what is this P2 plus P1 by 2? This is P1, this is P2. Okay, it's a linear graph, so we can say this is average value of that. So half P1 plus P2 into V2 minus V1. Directly, if also you remember, you can find its answer. Okay, what is it? Half P1 plus P2 into V2 minus V1. This is work done. Positive work done, negative work done. Positive work done, because volume is increasing. Volume is increasing. This is the work done in this process. right? Note it. Then now let's extend this one. Let's make another question over here. Suppose this time I make it like this. Okay, it goes in this way, then it comes in like this, and then it comes back like this. This is A, this is B, this is C. Okay, the gas goes from A to B, then from B to C, then from C to A. Values I'll give you. Let's assume this is 2 atmospheric pressure. Okay, and this is 5 atmospheric pressure. This is 1 liter, and here you say 3 liter. Right? Every value I have given. What we have to do? The question. So find all the things, whatever are possible. No, everything we'll find. Okay. What is that? First, find work done in AB, work done in BC, work done in CA separately. Okay. Then what else we can do? Shall we find internal energy also? But for internal energy, I have to talk first about ideal gas equation. Ideal gas equation I need to tell you, then only you can find it. Okay, what is ideal gas equation? It is basically a relation between the parameters, physical parameters of the gas at any state. At any state. At A you can use it, at B you can use it, at C you can use it. Okay, it's a state function. Okay, it gives you a relation between pressure, volume, temperature, number of moles. Okay, at any state, at any position. And what is ideal gas equation? We all know that. Okay, it is actually PV equal to nRT. And how it came? It came from basic laws that we have: Boyle's law, Charles' law, Gay-Lussac law. Okay, so from there it has come PV equal to nRT. Right, so remember that also. So PV equal to nRT means is, can I apply here PAVA equal to nRTA? Yes. PBVB equal to nRTB? Yes. PCVC equal to nRTC? Yes, we can do. Okay. The number of moles also I will give you here. Let's say take it as number of moles is 1. Okay. So WAB, WBC, WCA we know now. Correct? No doubt about that. Now, if I say you helium gas we have taken. Okay, that's for helium gas. Question is for helium gas. Why I am saying it? Because I want to involve Q also in that. That's why I am doing it. Or delta U, not Q at the moment. We will involve delta U only, or U only. So let's say find UA, UV, and UC. And then what? This is one thing. Then third thing, this is first question, this is second question. And third question you write is find delta U, delta UAV, delta UBC, delta UCA, and finally delta UABCA. Here also, no? WAB, WBC, WCA, and WABCA. And for full process, how much is work done? Okay. So this, all the things we'll find. This is the question. Okay. Come on, note it, because I'll remove this one and remove this one also, and then we'll find it. Okay. So do it fast. This is for helium gas. So helium I'm writing here. Okay. Note it fast. Note this question. Right? Okay. Let's move. So I'm just clearing this one. right? I am clearing this also here, right? So let's start a solution. First is work done in AB. The work done in AB is the same question that we did little while ago, right? Work done in AB, how to find? We said that area under that. Area under that means this entire area, okay, or this entire area. So in that one, this rectangle also will come, in this triangle also will come. Okay, so how we found it? Directly shall we do? This is half P1 plus P2. P1 plus P2 is 2 plus 5. 2 plus 5 atmospheric. Atmospheric we have to convert into Newton per meter square. 1 atmosphere equal to 1 into 10 to the power 5 Newton per meter square. You have to remember that. Okay. Into V2 minus V1. V2 minus V1. V2 minus V1 is 3 liter minus 1 liter. That is 2 liter. 2 liter. We have to convert this in meter cube. So 2 into 10 to the power minus 3. 2 liter means 2000 ml, 2000 cc, and 1 cc equal to 10 to the power minus 6 meter cube. Okay, so it will become 2 into 10 to the power minus 3. Now everything is in joule. Okay, 7 by 2 into 2 into 10 to the power 2. This is 2 into 10 to the power 2. 2 and 2 cancel. Answer is 700 joule. Work done in AB. Work done in BC. Okay, so work done in BC, you can see that delta V is 0. No change in volume is happening. Okay, here volume and here volume. At both the places, volume is 3 liter only. So no change in volume. No change in volume, no work done. Okay, so WBC 0. Okay, and one more thing. In this one, volume is increasing or decreasing? Increasing. So work done is positive. Okay, this is positive work done. Positive 700. Okay, work done is CA now. Work done in CA, you can see the pressure is constant. It's a constant pressure. So constant pressure means P delta V we can write directly. Yes, we can write. But it's in the graph. So let's say area under that graph. Under this one is what? This alone. That means area of this rectangle alone. Okay, so work done in CA. So what? Height into base. Okay, height into base. What is height? 2. Base is what? 2. So 2 atmosphere into 2 liter. 2 atmosphere. 2 into 10 to the power 5 into 2 liter. That is 2 into 10 to the power minus 3. Perfect. But now you see that here volume is decreasing. The volume is decreasing what? Negative work. This is negative. What's coming? 2 into 2, 4. So minus 400. Minus 400. Now then, work done in entire process, work done in ABCA. How to find? Work done in this plus work done in this plus work done in this. That's it. Okay. Work done in AB plus work done in BC plus work done in CA. How much is going to come? That's 700. This is minus 4. 700 plus 0 minus 400. That is 300. Perfect. Absolutely fine. But if suppose in this question I would have asked you only this. So do I have to find this work done, and this work done, and then I'll get the answer? Answer is no. No. We have to understand that through the graph so that we can find it. Okay. So what it is now? Now suppose I am talking about work done in which process? AB. Work done in process AB was what? This. This entire thing is work done in process AB with blue. Okay. Then work done in process AC is what? Work done in process AC is this one. Correct? Work done in ABCA is what? What you have done? Work done in AB minus work done in CA. Subtract it. Work done in AB minus work done in CA. That means from this entire thing, you have subtracted this. So what's coming? This alone. Okay, this alone is coming. This alone. So in this process, work done will be area under this cyclic process. This is called cyclic process. If you are starting from one point and you are returning back to the same point, this is called a cyclic process. What is this process? Cyclic process. And in cyclic process, what is work done? Area under the cycle. Area under the process. Understood? So I would say here, this is actually area under, not area below. So far what we did in AB, we did area below, area under. Okay, area under the curve, area under the graph. That's what we did so far. But this is not area under, area within. So area under should not write. Okay, here also I should not write area under, area within the cycle. For which one? Cyclic process. Okay, so what do you do? I'll just find area of this triangle, nothing else. So the area of triangle is what? Half base. Base is what? 2 liter. So that is 2 into 10 to the power minus 3. Correct? 2 into 10 to the power minus 3 we are writing. Okay, so half base. Height is what? Height is this minus this. This minus this is what? 3 atmospheric pressure. So 3 into 10 to the power 5. Okay, 2 and 2 cancel. This is 3, so that is 300. 302. Direct answer. Okay, so in a cyclic process, just find area within the cycle itself. That is the area work done in cyclic process. Right? Note first. Okay, done. So now what we have done? We found work done. Work done in this process. Right? Now what? We have to find internal energy. Okay, so I'm just clearing the board. So here it is. So board is clear for us. And this I'm not clearing. Okay, without that also we can find internal energy. Okay, so internal energy. Which internal energy first? UA. Can I find UA? Why not? UA. Now internal energy was what? N into F by 2 RT. N F by 2 RT or NCVT. Correct or not? NCVT. Both are same. Because CVs is F by 2R. F is what? Degree of freedom. Which gas we took? Helium. Monoatomic gas. Helium is monoatomic gas. Monoatomic gas means is what is degree of freedom? 3. And number of moles also we have taken, number of moles is 1. So number of moles we'll write 1. This is 3 by 2 R. F by 2 R. F is 3. So 3 by 2 R. T. Temperature at A. Now that we have to find. How to? Ideal gas equation. PAVA equal to nRTA. Okay, so PA is what? 2 atmospheric. So this is 2 into 10 to the power 5. VA is what? 1 liter. That is 1 into 10 to the power minus 3. Number of moles 1. R I will write R only. I am not writing it as 8.314 at the moment. Okay. So TA. So what it is? This comes out to be 200. 200 by R is TA. Very good. We got it. I am going to put in that one. Because it's UA. So it's NCVTA. Okay. So into what is TA? 200 by R. Correct? Yeah. So R and R gets cancelled. Okay. And this is 100. So UA is coming 300 Joule. Okay, internal energy at A is 300 joule. Internal energy at B also we can find, right? So internal energy at B in the same way, NCV TB. And how to find TB? Ideal gas equation. PBVB equal to NRTB, right? Okay, directly I am doing it. So this is 1, CV is again 3 by 2R, same gas. TB is what? PB by NR. So PB is what? Check PB, 5 atmospheric. 5 into 10 to the power 5. VB, 3 liter. 3 into 10 to the power minus 3. So PBVB by N is 1 to R. Right? R and R cancelled. Okay, now what we have? This is 3 by 2. And here we have 1500. Okay, so this is 750. 750 into 3. I think this will be 2250 joule. UV. Correct. Same way UC we can find. Okay, UC also we can find. What is UC? Let's see. So UC is here. What is that? NCV DC. So N is 1. This is 3 by 2R. TC. PCVC by NR. PCVC by NR. R and R cancelled, N and N cancelled. N is 1 only, right? But if N was there, still we could have cancelled it. So 3 by 2. PC is what? PC is 2 atmospheric pressure. So 2 into 10 to the power 5. VC is what? 3 liter. So 3 into 10 to the power minus 3. 2 and 2 gets cancelled. Answer is, this is 3 into 3, 9. 10 to the power 5 into 10 to the power minus 3, 10 to the power 2, so 900. Done. Change in internal energy you want to find? UAB, UB minus UA. NCB, TB minus TA we can write directly because it's the same only, no? NCB is common. So TB minus TA we can write. Okay. Finally, in entire thing, see if UAB you have to find UB minus UA. BC you have to find UC minus UB. CA you have to find UA minus UC. We have found already individual. But if suppose I want to find ABCA, what it is? So final temperature is A and initial temperature also at A. So change in internal energy will become 0. Delta U ABCA is 0 because final position also A, initial position also A. So temperature final is also TA, temperature initial also TA. So NCV TA minus TA. That's only, no? Change in internal energy. NCV T final minus T initial. Correct? So it will become 0. So this is how change in internal energy we can find with the help of ideal gas equation. Okay? And we can also find the work done with the help of graph. Correct? Clear this one? Okay. Shall we go ahead? Okay. Let's see another question in the graph only. Okay. Question is something like this. Okay. This is A, B, C. Okay. And there is another way to reach C, that is A, D, C also. Right? But this question I should ask you after telling you first law of thermodynamics, not before. Okay, fine. So work done, we have discussed already. Ideal gas equation also we have discussed already. Okay, now let's discuss about first law of thermodynamics. First law of thermodynamics. First law of thermodynamics. The first law of thermodynamics basically is what? Another form of conservation of energy. Okay, another form of conservation of energy. Okay, so what it says that if there is a system, what sort of system? System normally we show that if there is a cylinder, okay, cylinder is there and then we have a piston. Okay, this is our system, and in this system there is gas also. Definitely gas has to be there. Okay, there is gas or dots you can make. And dots means is it takes more time, right? Okay, fine. These are dots. Whether they are visible to you or not, that I don't know. Okay, there are dots in this. Small dots are there. So this is gas, right? Now here what is there? This we are saying this is our system. And here definitely something will be there, like atmospheric pressure will be there. Okay, this is atmospheric pressure. And this is an equilibrium. We are saying it's an equilibrium. That means the piston is not moving, it's at rest. Now suddenly you have given heat. You have given heat to that, okay? Huge amount of heat we have given. What it is going to do? These molecules will get the heat. When get the heat means is what will happen first? The kinetic energy will increase. Kinetic energy means internal energy. Internal energy will increase. Kinetic energy will increase. So what they will do? They will collide with this piston with more speed. Right? Earlier also they were colliding, depending on what the temperature was. Okay? They were colliding and they were balancing the piston because they only are colliding and applying the force on the piston. Because force, this is also when we say atmospheric pressure is there. So this atmospheric pressure is also applying force downwards. Right? So you have to balance it. Who's balancing? These particles. They are going and colliding with it and applying the force. So that force and the force applied by atmospheric pressure were equal. So they were in equilibrium. Now you have given them energy. The kinetic energy increased. The kinetic energy increased. They are going to collide with the more force, more momentum. So they are going to exert more force. So what will happen now? Force exerted by these molecules have become more. So, right or not? It will go up. Expansion. So, first law of thermodynamics says that if the heat Q is given to the system, okay, it is utilized in increasing the internal energy and work done. It is used in increasing the internal energy and work done. Now, here temperature is increased, yes, the kinetic energy increased, yes, they applied more force on the piston, yes, because of that piston has moved up, and then at some point it will again come in equilibrium. Again come in equilibrium means what? Now again these are going to apply the force. These particles are again applying some force on the piston, right? Applied by this is equal to the force downwards. It has expanded. Yes or no? It has expanded. Right. So now according to that, what we will say? Expansion has also happened. Okay, and internal energy also has increased. So because of what it has happened? Because of this Q. So heat applied or heat supplied to the system is utilized in two ways. One, in increasing internal energy, and second one, in doing work. Both has been done. So this is called first law of thermodynamics. Heat supplied to the gas is utilized in increasing the internal energy and doing positive work. Why I am saying positive work? Because expansion is happening. So delta Q or Q equal to delta U plus W. If we keep the value NCV delta T plus P delta V if the pressure is constant, otherwise PdV. Right? This is first law of thermodynamics. Understood that? So Q equal to change in internal energy plus work done. Clear? Note this one. Done. Okay, fine. Now, if it is given to us, suppose it's given like this. A general question I am asking you. If suppose there is a PV curve given, and in this one the graph is like this. Okay, maybe this we can same value is we can say 5 atmospheric here and 2 atmospheric. This is volume. How much we took? 1 liter, and this was 3 liter. Process is like this. This one work done is positive or negative? Positive. Volume is increasing. Pressure is decreasing, no doubt, but still volume is increasing. Volume increases means expansion, expansion means positive work. Okay, work done will be positive. Here also we can find it very easily, right? We can find it very easily. And how much will be the work? Same thing, like area under this. Okay, so area under this, if you are finding, work done is what? Work done is, again, if suppose triangle we take, so half base is what? 2 liter. So 2 into 10 to the power minus 3. Height is what? 3 atmospheric. So 3 into 10 to the power 5. Plus rectangle. So 2 atmospheric. 2 into 10 to the power 5 into base is 2 liter. 2 into 10 to the power minus 3. Or you can take average pressure and change in volume. Okay, the same thing. So what's coming here? This is coming 300 and this is coming 400. There is 700 joule, but this work done is negative. Sorry, this work done is positive because volume is increasing. Remember, if it is opposite way, like this, and this one volume is decreasing, so this will become minus 700. Remember that. Okay, another question I'll ask you. Okay, another question we will see. Okay, what is the question? In this one, your cycle is given in the form of circle, like this. Okay, this is point A. Okay, this point B, and then back to A. Right? The pressure and volume. Let's assume this is 1 atmospheric. This is 3 atmospheric. Okay, this is 1 liter, and this is 3 liter. Now, what is asked from us? say that work done in AB you find, and then work done in cyclic process you find. Cyclic process means you start from A, come back to A. Okay, so first is work done in AB. Okay, then work done in ABA. What are we going to do? In ABA, it's very easy for me to find. It's a cyclic process, and I learned that in a cyclic process is area within the curve, within the graph. So within the graph means circle, circle's area, pi r square. Okay, it's pi r square. So okay, fine. Work done in ABA is area within cyclic process. So it's pi r square. But what is the radius? What is the radius? So radius here. Okay, which one? How we are going to take the radius? We talk about diameter. Okay, and the radius also. This term is written in terms of volume, and this term is written in terms of pressure. Okay, so we have to take both. That means we are going to write pi r1 into r2, not pi r square. Remember that. Okay, so what is r1? Pi. Okay, pi is as it is. R1. So suppose R1 I am going to take this one. This is R1 for me. And this is R2 for me. Okay. What is R1? You see that this is diameter. How much is diameter? 3 atmospheric minus 1 atmospheric. 2 atmospheric pressure is diameter. So radius will be half of that. So 2 atmospheric pressure by 2. 3 minus 1 is 2 atmospheric. That is diameter. Diameter by 2 is radius. So 2 atmospheric. That means 2 into 10 to the power 5. Then R2. R2 is this. So see, this diameter is what? 2 liter. 2 liter by 2. That means 1 liter. So 1 into 10 to the power minus 3. What we are getting then? 200 pi joule. 200 pi joule is the work done. Okay, but now question is positive or negative? Positive work done or negative work done? Answer is positive work done. This is positive. The question is how I found. What I did is, I broke this in work done in AB and work done in BC. Okay, change in volume is same in both. Here also change in volume 2 liter, in the back side also change in volume 2 liter, correct? But upper side pressure is more. Work done is what? P delta V only, no? So upper side here pressure is more. For same change in volume, more pressure is there. That is more work be done in the upper side. Lower side, less pressure is there. So that's why work done will be less here. So in this one, there is compression. So that means negative work. Where? Downward. And the upper side, there is expansion, volume is increasing. So more work is done in expansion, less work is done in compression. So that's why positive. Correct? Yes or no? Now we'll make it as convention. If there is a PV graph, there is a PV graph. If you are moving clockwise, the cycle is clockwise, then work done is positive. Okay. In a PV graph, if a cycle is clockwise, then work done is positive. Work done is positive. If it is anti-clockwise, then negative. Okay. If cycle is anti-clockwise, then work done is negative. Then note this. Okay, done this one. Now this is how cyclic process work done we can calculate. If it is clockwise, then directly we can write positive and then find area. There is no issue in that. Okay, right. So before this, before first law of thermodynamics, I was making one question, right? Now can we do it? We can. Okay, but before that, Q heat given, we should find. Okay, in the previous question we did, can we find that? Yes, one question we did, no work done. We found work done. We found change in internal energy. In that one, we can also find Q value. So let's do one question. Okay. After that, we will go for the question which I was making. A simple question we will go. We'll do. So what question we will solve? Like this, we will solve now. This is P and this is V. Okay, fine. Like this we will do, and okay, let's make cyclic one. Right. This is A, this is B, this is C. Let's put values also. Say 1 liter. Sorry, 1 liter, it's pressure. So 1 atmospheric, 3 atmospheric, 1 liter, and 3 liters. Okay, so what I want Q in this. Now we all know that how to calculate work done, how to calculate delta U, everything we have done. Only thing is Q we have to find. First law of thermodynamics we want to use on this one. Okay, so find heat exchanged during this cyclic process. Okay, fine. What is heat? Heat exchange during cyclic process. What is that? ABCA is equal to delta U ABCA plus work done ABCA. That's what first law of thermodynamics is, right? Okay. Now, since it's a cyclic process, you are returning back to A. Change in internal energy is 0. Because change in internal energy or internal energy is a state function. You are reaching to the same state. The change in internal energy is 0. It's gone. That means QABCA equal to WABCA. Yes. In this case it is. But if suppose I would have asked you QAB, then delta U was not 0. We would have found delta U. We would have calculated work done and we would have written it. Correct or not? Shall we do that also? Okay, we'll do it. First, let's do this. So ABCA now. Now ABCA means what I have to do? It's a cyclic process now. So just calculate area within this. That means area of the triangle. How is the motion? Clockwise. So work done is positive. So just write it. Okay. It's a half base. Base is what? 2 liter. 2 into 10 to the power minus 3. Height. 2 atmospheric pressure. So 2 into 10 to the power 5. Okay. What it is? Half and half. So rather 2 and 2 cancel. It's 200 joule. Positive. That's what GT is given. Okay. Now in process AB. Okay. Let's see. QAB delta UAB plus work done in AB. Okay. Delta UAB we have to find. So first I have to tell you gas also. Without gas it's not possible. So let's take helium only. Okay, number of moles also I have to say. Take 1. Okay, so fine. This is NCV delta T. TB minus TA plus work done in AB. Work done in AB means it's this triangle also and this rectangle also. Area under the graph. Okay. So what it is? In this one, in triangle already we found 200. Now only this I have to find. Right. So this is what? 1 into 2. I'm doing it, okay. I'm just writing it, okay. This one 200 plus this area I'm writing. This area. 1 atmospheric, that means 1 into 10 to the power 5. And this is 2 liter, 2 into 10 to the power minus 3. Right? Okay. Now this one you see. 1 into 3 by 2R. TB minus TA. Now we have to find temperature. So how to find temperature at B? Ideal gas equation is there. So TB will be what? PB VB by NR. What is PB? 1 atmospheric. 1 into 10 to the power 5. What is VB? 3 liter. 3 into 10 to the power minus 3. Okay. By NR. Let it be NR only. So what's coming here? This is 300. Okay. So TB is 300. By NR. That is 1R. Minus TA. TA we have to find. The TA is what? PA VA by NR. What is PA? 3 atmospheric. 3 into 10 to the power 5. A VA 1 liter. 1 into 10 to the power minus 3 by 1R. Okay, what's coming? 300. 300 by 1R. 300 by 1R. And here 200 plus 200, that is 400. So it comes out to be change in internal energy 0. The temperature here and temperature here is same. Okay. We can't do anything in that. Right? The change in temperature is 0 because temperature at B and temperature at A happens to be same. Fine. No issues in that. The change in internal energy is 0, but work done here is 400. So delta Q or QAB rather is 400 joule. Okay. So today's class we are finishing here only. In the next class we will study about various thermodynamics processes also, and we will make all the questions, all type of questions which are there in thermodynamics, we will solve in it. Okay. Bye for now. See you in the next class.